Hello and thank you for watching my video. My name is Astrid Krasniqi. Today we will be covering Chapter 9, Subnetting IP Networks. This is a part of CCNA Semester 1, Introduction to Networks. Chapter 9, Subnetting IP Networks Objectives. This lesson is divided in 3 sections. We have section 9.1, Subnetting an IP Network. In this section we explain why routing is necessary for hosts on different networks to communicate. And then we describe IP as a communication protocol used to identify a single device on a network. Then, given a network and a subnet mask, we need to calculate the number of host address available. And then we have to calculate the necessary subnet mask in order to accommodate the requirement of a network. Then we move to section 9.2, addressing schemes. In here we describe the benefits of variable length subnet mask, VLSM. And then we move on to section 9.3, designing consideration for IPv6. Here we explain how IPv6 address assignments are implemented in a business network. Okay, we start with section 9.1, subnetting an IPv4 network. This is again part of chapter 9, subnetting IP network, CCNA semester 1. Reasons for subnetting. Subnetting is the process of segmenting a network into multiple, smaller network space called subnetworks or subnets. Large network must be segmented into smaller subnetwork, creating smaller groups of devices and services too. We have to control the traffic by containing broadcast traffic within each subnetwork, and we reduce the overall network traffic and improve network performance. Communication between subnets. Traffic cannot be forwarded between subnets without the use of a router. Every interface on the router must have an IPv4 host address that belongs to the network or subnet to which a router interface is connected. So for example, we have one large subnet here, and then this large subnet we subnet it into 2 smaller subnets, and we call it subnet A and subnet B. So the router connects to one network. Each interface has got its individual network. One interface cannot belong to two interfaces cannot belong to the same network. The plan. Planning network subnets require examination of both the needs of an organization network usage and how the subnets will be structured. The address plan includes deciding the needs for each subnet in terms of size, how many hosts per subnet, how host addresses will be assigned. Will we give the host a static IP address or a dynamic address through DHCP. Now, subnetting the selected private IP address space will provide the host address to cover up your network needs. For example, remember the private IP addresses. The range was the first, class A, 10.0.0.0 with the subnet mask 255.0.0.0. So the range from 10.0.0.0 up to 10.255.255.255. Then we had class B. Class B range was from 172.16.0.0 with the subnet mask of 255.240.0.0. Remember the range was 172.16.0.0 all the way up to 172.31.255.255. Then we had the class C, which is 192.168.0.0, and the subnet mask for this is 255.255.0.0. So the range was from 192.168.0.0 all the way up to 192.168.255.255. Now, this is a different kind of ranges that we can use. We can use class A, for example, if our network is massive and we want to assign class A address, and then we can subnet that into smaller subnets. Class A address will give you just above 16.7 million addresses. Then we have the class B addresses, which each network will give you about 65,000, just over 65,000 65,000 host IP addresses. And then we have a class C range, which each network will give us 254 host addresses. Now, subnetting an IPv4 network, every network address has a valid range of host addresses. All devices attached to the same network will have an IPv4 host address for that network and a common subnet mask or network prefix. When we say prefix and the subnet mask are different ways of representing the same thing, the network portion of an address. IPv4 subnets are created by using one or more of the host bits as the network bits. This is done by extending the mask to borrow some of the bits from the host portion of the address to create additional network bits. The more host bits we borrow, the more subnets can be defined. For each bit borrowed, the number of subnetworks available is doubled. For example, this is our address. We have a network portion. Network portion is identified in subnet mask by placing ones in there. And then we have a host portion. Host portion is defined by subnet mask by placing zeros in there. So we have a network 192.168.1.0. And the subnet mask is 255.255.255 all ones. Now when we take this network address, the zeros are the ones that we can manipulate. We can start borrowing the zeros to create extra subnetworks. So this is one subnet, 192.168.1.0, it's one subnet. If we want to create two subnets out of this subnet, we have to borrow this zero. Now the subnet rule says the ones, they have to be contiguous on the left, and the zeros, they have to be on the right. So for example, if you start borrowing zeros into ones, you have to start borrowing this zero. You can't borrow this zero here. So remember, if we create extra networks, we have to start borrowing these zeros and changing them into ones. Here, 8 zeros will give us 254 hosts. If we borrow 1 zero, we double the subnets from 1 to 2, but we reduce the zeros for a host, so we have only 7 zeros. 7 zeros will give you only 126 hosts. So if we borrow 2 zeros, for example, that will give us 4 networks. But then we kind of like half, little bit more than just half our host IP addresses. We'll see that in the future slides. So for example, we can see here on the subnetting an IPv4, and this time we create only 2 subnets. So we have this address, network address. So we have a 192.168.1.0. This is represented in in binary on this side, and with the subnet mask of 255.255.255.0, and this is represented in binary here. We can manipulate or borrow any of the zeros we have. So these zeros we can manipulate. If you look at the subnet mask, we cannot manipulate the ones. The ones are already given to us by ISP or another whoever has been subnetting before. But the thing is that these ones here that we have, we cannot touch. The zeros, on the other hand, are ours. We can do whatever we want. We can manipulate them and create extra networks. So if you look at the subnet mask, it has 8 zeros. Here we have 8 zeros. If we use the formula 2 to the power 8 minus 2, it will give us 254 hosts. Okay, now maybe we don't want the 254 hosts in one network. We want to separate this and make it 2 networks. So we can, if we want to make 2 networks, we have to borrow 1 bit from the host portion of zeros. So we have 8 zeros here, we borrow 1 of them. We create that, we change it into 1. The reason why I cannot borrow one of these zeros, other zeros, is because the subnetting rule says that ones, they have to be on the left, and the zeros, they have to be on the right. You can't mix and match. Left, ones, zeros, right. So the subnet mask will become 255.255.255.128 now. The reason is, this bit here, it represents 128. Now, if we look at it, we'll get 2 networks. And each network will have 126 usable IP addresses to assign. If you remember the formula, for the network was 2 to the power n. For the host, 2 to the power n minus 2. Where this n is how many ones you have. So here we took 1. So 2 to the power 1 will give us 2 networks. And then that will leave us with the 7 zeros. Now 2 to the power 7 minus 2. 2 to the power 7 is like saying 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So 2 to the power 7 is 128, minus 2 is 126. So that's what we're saying. We'll get 2 networks, and each network will get 126 usable IP addresses. 126 addresses available to assign to hosts. Now, here we can start assigning the IP addresses. So we had 192.168.1.0. That's what we started with. That's the subnet mask that we started with. We borrowed 1 bit and we changed. Now the start of the IP address of the network address did not change. but our subnet mask has changed. If you look, it's changed now. This 1 is representing 128. So our subnet is 255.255.255.128. So if we put it on the table, it's something important to see. We need to know network ID, what we're going to represent our network, first valid address to assign it to host, last valid address to be assigned to host. Everything in the middle is all valid. And then we have a broadcast address. Broadcast address means everybody on that network that you can talk to. So for example, if you look at this network, 192.168.1.0/25, broadcast address will mean anybody on that network. If you want to talk, you send a broadcast message. So we start with 192.168.1.0. This is what we started with. First valid address is 192.168.1.1. 1 extra than that. Last valid and broadcast is better if you find the next subnet, which is 192.168.1.128. But how did I find that it's 128? The reason is we need to know what is incrementing our subnet. So if we borrowed 1 bit, this bit is 128. So it means that it's incrementing. Our subnets are incrementing by 128. So 0 plus 128 is 128. So then we need to find out the broadcast for the first network, which is this minus 1. So 192.168.1.127. And then the last valid is 126. So it's a broadcast minus 1. So what about subnet 2? Subnet 2, it starts with 128. The first valid is network ID plus 1, which is 192.168.1.129. And then it's here written, but how did I find out? I can look at the range. What's the increment on? So 128 plus 128 here is representing is 256. 256 is not allowed. There's no 256 in IPv4. So we know we reached the end bit. So this broadcast is 192.168.1.255. And the last valid address is 254. Both subnets are using the subnet mask 255.255.255.128, or I can say prefix 25. We take another example. Subnetting in IPv4, 4 subnets now. So again, we started with 192.168.1.0. The subnet mask is 255.255.255.0. Again, so you don't forget, we can manipulate or borrow the zeros, but we cannot manipulate or touch ones. So in this time, if we borrow 2 bits from host portion, so these zeros are ours, we can do whatever we want. So we borrow 2 bits. Again, we can't go and mix and match, we have to start on the left, so we borrow 2 bits. Now the subnet mask is changing to 255.255.255.192. The reason is, this bit is represent 128. You have to add this bit as well, which is 64, that gives you 192. With this, with 4, it will give us, if we borrow 2 bits, will give us 4 networks, and each network will have 62 usable IP addresses to assign. Again, if we don't forget the formula, for the networks the formula was 2 to the power n, for the host the formula was 2 to the power n minus 2. So 2 to the power 2, which is these 2 bits here, that's n, equals to 2 times 2, which is 4. This will leave us with the 6 zeros. So 2 to the power 6 minus 2. It's like saying 2 times 2, 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the power 6 is 64, minus 2 equals to 62. 62 usable IP addresses to assign. Now, if we want to put them on the table, because it's important to know how to assign these addresses. For example, we have to start with network ID 192.168.1.0. That's subnet 1. The first valid address for subnet 1 is subnet ID or subnet 1 plus 1. So 192.168.1.1. To find the last valid of the broadcast, we look at what are the subnets incrementing. What's the numbers? What's the bits? So we have to look at the division, where the ones and zeros are divided. This bit here, whatever is representing this bit, that's our increments. This bit represents, the second bit represents 64. So our increments are on 64. So 0 plus 64 is 64. So the broadcast address is the subnet 2 network ID minus 1. That's the broadcast address for subnet 1. So 192.168.1.63, and the last valid address is 62. Then subnet 2, first valid address is 192.168.1.65. So it's subnet ID for subnet 2 plus 1. Now the last valid in broadcast is easier to find out what's the next subnet ID. So 64 plus whatever that bit is representing is another 64. So what's 64 and 64 is 128. So subnet 2 broadcast address is subnet 3 network ID minus 1. So 192.168.1.127. And then last valid is 126. Subnet 3 address is 192.168.1.128, with first valid address 192.168.1.129. And then to find the last valid in broadcast, it's better if you find the next subnet ID, which is 128 plus 64, which is 192. Okay, now what I'm gonna do is I'm gonna run through we're gonna create one subnet for ourselves. So what do we want is, imagine that we need, I don't know how many subnets we want to take. Let's go through here. So say that we want 6 subnets. 6 subnets. Now this is the IP address, network ID that we were given. This is the subnet mask that we are given. We can manipulate the zeros, but we can't touch ones. So if we borrow, how many bits we need to borrow? How many bits we need to borrow to create 6 subnets? So when you think of the formula, always remember the formula. 2 to the power of what will give you at least 6 subnets. So if we say, okay, let's just copy this here, and then we can delete it. Here. Okay, the network was 2 to the power of n. That's it. So how many of these n's we need to create 6 networks? So if we have 1, it will give us 2 networks, which is 2 times 1 will give us 2 networks. That's not enough. So if we need 2, 2 times 2 is 4. So that's not enough. If we have 3 bits, right? Now 2 times 2 is 4, times 2 is 8. So yeah, we're gonna need 3 bits to borrow. Right, so now we're gonna borrow 3 bits like this to create at least 6 networks or 6 subnets. Now we're creating 8, but hey, that's the closest we can get. So let's borrow 3 of these bits, right? I'm gonna change these to ones. So 1, 1, 1. Okay, we've done that. Now our subnet mask has changed from 255.255.255.0 because we borrowed these 3 bits, so we have to add them together. So this is 128 plus 64 is 192 plus 32 is 224. So our network is 224. Our subnet mask is 255.255.255.224. Now we're gonna need to put it on the table, right? So we start with subnet 1, 192.168.1.0. That's what we started with. Then we give it the first valid address. The first valid address is subnet 1 plus 1. So 192.168.1.1. To find the last valid address and a broadcast, it's easier if we find the next subnet ID, right? So subnet 2 network ID. It's going to be 192.168.1. What do I say that? I say that because it's already been these ones. We didn't change this. 192, the first 3 octet, we didn't change. 192.168.1. But something else, the last octet. Now, we need to find out where is the division happening. It's here, between the ones and zeros. Now, whatever this 1 represents, that's our increments. That 1, if you look in from the table, it will represent 32. So our increments are in 32s. Okay, we found that out. So the broadcast address of subnet 1 is the network ID of subnet 2. So it's going to be 192.168.1.31. Last valid address for subnet 1 is going to be the broadcast address minus 1. So 192.168.168.1.30. Okay, so we can see there's 30 valid host addresses that we can give. Now, if we look at the formula for the host, yeah, you remember the formula for the host was 2 to the power n minus 2, yeah. Right, let's just write it here somewhere. for the host network was 2 to the power n. For the host, the formula was 2 to the power n minus 2. Minus 2, the n here. Right, so with 3 bits, we had 2 times 2 times 2. That will give us 8 networks. For the host, when you look, we have 5 zeros left, right? So the formula is becoming 2 to the power of 5 minus 2, right? It's like saying 2 times 2 times 2 times 2, 5 times 5. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this equals 32. So 2 to the power of 5 equals 32, minus 2 is 30. So if we borrow 3 bits, 3 bits is giving us 8 networks, and is leaving us with the 5 zeros, and 5 zeros are for the host, and they are giving us 30 available hosts. So we can see first valid is 1, last valid is 30. Okay, let me get rid of that. Now, for the subnet 2, the first valid address is subnet 2 network ID plus 1, which is 192.168.1.33. The last valid and the broadcast, it's easy if you find the subnet 3 then subnet 3 network ID. So let me write here subnet 3. What is the network ID for the subnet 3? If we look at subnet 2 network ID plus whatever we increment in by 32 on the 4th octet. So that's going to be our subnet 3 network ID. So 192.168.1.32 plus 32 on the 4th octet is 64. Excellent. So on subnet 2 broadcast is subnet 3 ID minus 1. So the broadcast is going to be 192.168.1.63. Valid address, last valid address is going to be 192.168.1.62. Okay, so the range for subnet 2 is from 33. So from first valid 192.168.1.33 to last valid 192.168.1.62. So subnet 1 and 2 is done. Now subnet 3. Subnet 3, first valid address is going to be subnet 3 ID plus 1, which is 192.168.1.65. To find the last valid and broadcast, it's better if you find the next subnet ID, which is going to be subnet 4. Subnet 4 network ID is going to be 192.168.1.64 of subnet 3 plus 32 here. This is very important, this number here is representing 32, so we're going to add 64 plus 32 is 96. Right, so subnet 3 broadcast address is subnet 4 network ID minus 1. So 192.168.1.95. Last valid address of subnet 3 is the broadcast minus 1, which is 192.168. 168.1.94. Okay, now subnet 4 first valid address is going to be the subnet ID network ID plus 1, which is 192.168.1.95. Again, to find the last valid and the broadcast is easier if you find the next subnet ID, which is subnet 5. Subnet 5. Subnet 5 network ID is going to be 192.168.1.96 plus 32. So we can look, 196 plus 32 is 128. Now, the subnet 4 broadcast address is subnet 5 network ID minus 1. So 192.168.1.127. Last valid address is a broadcast minus 1. So 192.168.1.126. Okay, subnet 1, 2, 3, and 4 done. We move to subnet 5. Right. Let me just make some space here. Right, so we're gonna finish this. I mean, you can fast forward it, but you can see what's happening here. Subnet 5 First valid address is network ID plus 1, so 192.168.1.129. To find the last valid address and broadcast, it's better if you find the next subnet ID, so subnet 6. Subnet 6 network ID is subnet 5 plus the 1 there. Oh, I deleted the 1. Let me just put it here. We borrowed 3 bits, yeah? 3 bits. Let me put them on red, bold. Okay. 1, 1, 1, 1, and in decimal was 224. So this bit here was 32. It was representing 32. So subnet 6 network ID is subnet 5 plus whatever the division 32 there on the 4th octet. So we have to add on the 4th octet. Leave the 1st octet alone, 2nd octet is alone, 3rd octet is alone. The division is in the 4th octet. So we have to increment the 4th octet. So 128 plus 32 is 160. Yep. Now, subnet 5 broadcast address is subnet 6 network ID minus 1. So 192.168.1.159. Last valid address is 192.168.1.158. The broadcast minus 1. Subnet 6 first valid address is 192.168.1.161. Last valid address and broadcast is better again if we find the next network ID, subnet 7. Subnet 7 is subnet 6 network ID plus the increment on the 4th octet by 32. So it's 192.168.1.192. Okay, so the broadcast address of subnet 6 is subnet 7 minus 1. So 192.168.1.191. And the last valid is 192.168.1.190. Subnet 7 first valid address is the network ID plus 1, so 192.168.1.193. To find the last valid and the broadcast is easier again if you find the next network ID, which is subnet 8. Subnet 8 is network ID 192.168.1.what. So 192 plus 32, so 224, right? Now, the broadcast address is subnet 8 minus 1, 192.168.1.223, and the last valid is 192.168.1.222. For subnet 8, the first valid address is subnet ID plus 1, so 192.168.1.225. And again, to find the last valid and the broadcast, it's better if you find the next subnet, subnet 9. Subnet 9, which is 192.168.1.what? 224 plus 32 is 256. 256 is not allowed. Up to 255, 0 to 255. So, which means that we have reached the end. So there's no subnet 9. Okay, so let me delete that. There's no subnet 9. So subnet 8 is right at the top. Reached the end. 192.168.1.255. And then the last valid address is 192.168.1.254, which is broadcast minus 1. You can see we built the whole thing. We said earlier that if we, let me just delete that row. We said that if we borrow 3 bits, we will get 8 subnets, and each subnet will get 30 hosts. So this the first valid to last valid is the host range, what you can give. Okay. Right, now again let's look at the subnet, what we did. If we borrowed 3 bits, the formula has changed. Well, no, the subnet mask has changed to 255.255.255.224, and if we borrow 3 bits, we will get 8 networks, and each network will have at least 30 usable IP addresses. Now, if you look at the network formula, was 2 to the power n, and for the host formula was 2 to the power n minus 2. For the network 2 to the power of n, let me change that, 2 to the power n. Okay. 2 to the power n, which is, this n is like 2 to the power 3, yeah? 2 to the power 3, like this. 2 to the power 3 is like saying 2 times 2 is 4, times 2 is 8, so 8 networks. And we have 6, this should be 5, we have 5 zeros left here, 1, we counted, 1, 2, 3, 4, 5, 5 zeros. 2 to the power 5 minus 2, it's like saying 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so that is 32, minus 2, 30, right? Okay. Now if we look at the table, this is what we did. We continued. We did. We start here. I started, and then it will continue. It's important that you know the network ID. What's the network's incremented? Once you find out what is the network incremented, then you're easy to find out the first valid, last valid, broadcast, because it's -1, -1. Okay. Now we're gonna do in class B. So we're gonna need 100 subnets. Okay, so we have a subnet mask, the network ID 172.16.0.0 with a subnet mask 255.255.0.0. Again, we can manipulate or borrow zeros. We cannot manipulate or do anything with ones. So for 100 subnets, we need at least 7 bits borrowed, right? So here is our zeros. If we leave it to default, we have 16 zeros. We need, for 100 subnets, we need 7 zeros at least to be borrowed and to be changed into ones. If we borrow 7 zeros, we'll get 128 networks, which is more than what we need, but that's the closest we can get. And each network will have 510 usable IP addresses to be assigned. So if we look at the formula, 2 to the power n for the networks. So if you borrow 7 zeros, it changes into 1. It's formula saying like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, then times 2 is 64, times 2 is 128. So 128 networks. That leaves us with 9 zeros. It's like saying 2 times 2 times 2, 9 times, which is 512. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512. So 512 minus 2, 510. I have to tell you here, let me just go to that page. It's the next page there. I'm gonna add here something. 2 to the power of 10, right? 10 is 1024. It's like a milestone, yeah? So always think, okay, if you have like, what is 2 to the power 11? Think 2 to the power 10 is 1024. Double that, 2048. It's very easy. It's like a milestone. So just remember that 2 to the power 10 is 1024. So if we borrowed 7 bits to create 128 subnets, or 100 subnets that we needed, but we can, closest we can get is 128. Subnet mask will change to 255.255.254.0. So if you add all these up, it's 254. 128 plus 64, 192, plus 32, 224, plus 16, 240, plus 8, 248, plus 4, 252, plus 2, 254. So here we put it on the table. So the first subnet is 172.16.0.0. First valid address is subnet ID plus 1, 172.16.0.1. Now, to look at them, okay, let me just go here, right? And I want to delete all this so we can do it together. Let me just go and delete all this stuff. Delete this, and you can leave that. Okay, so subnet starts with 172.16.0.0. The first valid address is this plus 1. So 172.16.0.1, right? Okay, let me just copy the font so it will be all the same. Right? 0.1, yeah? No 1.0 because that's wrong, right? 1.0, no, 0.1. That's the first valid address. To find the last valid address and broadcast, it's better if you find the next subnet ID, which is subnet 2. In this case, 172.16 is the same. It will always be the same. Now, what you need to know is the increments. What we incrementing on. So we incrementing on the third octet. This is the third octet, and the zeros and ones are divided here. So this bit is representing what? Do you remember? This bit represents 2. So increments are in the third network by 2. 2.0. If we look at the broadcast of the subnet 1, is the subnet 2 ID minus 1. So 172.16.2.0 minus 1 is 172.16.1.255. Last valid address is a broadcast minus 1. So 172.16.1.254. So from 0.1 to 1.254 is actually 510 hosts. Okay, 0.1, 0.2, 0.3, 0.4, 0.5, and so on up to 0.255. Then it will be 1.0, 1.1, 1.2, 1.3 up to 1.254. And broadcast is 1.255. Subnet 2, first valid address, is the subnet 2 network ID plus 1. So 172.16.2.1. To find the last valid address and a broadcast, it's better if you find the next network ID. Right? Subnet 3. So again, 172.16. That doesn't change. So what? You remember? This bit here represents 2 and is located on the third network. Oh, sorry, third octet. So 2.0 plus 2 is 4.0. Right? Subnet 2 broadcast address is subnet 3 ID minus 1. So 172.16.3.254. Sorry, 255. Last valid address is a broadcast minus 1. 172.16.3.254. Okay. Now we did subnet 2, 1 and 2. We're doing subnet 3. Subnet 3 first valid address is 172.16.4.1. To find the last valid address and broadcast, is better if you find the next subnet, subnet 4, which is 172.16. Again, this bit represents 2, third octet. We increment the third octet by 2, so 6.0. Subnet 3 valid broadcast address is subnet 4 minus 1. So 172.16.5.255. And this 172.16.5.254. And it will continue like this for another 125 subnets. All subnets are using the same subnet mask 255.255.254.0 or /23. Now, to consideration when planning subnets, we need to know number of subnets we require and number of host addresses required. Formula to determine number of usable hosts is 2 to the power n minus 2. 2 to the power n, where n is the number of remaining host bits, is used to calculate the number of hosts. The subnetwork ID and broadcast address cannot be used on each subnet. Reason what he's saying here is this: the network ID represents our network, and the broadcast, we can't assign them to addresses, to hosts. Only from the first valid to the last valid, that range you can assign it, not the ID and not the broadcast. That's why we have the minus 2. So always remember this formula when you're doing the subnetting. 2 to the power n is for the networks, 2 to the power n minus 2 is for the host. Subnetting rules says ones, they are on the right, zeros on the left. Like 255.255.00 is like saying all the ones, 16 ones on the left and 16 zeros on the right. There is no way, you're not allowed to, hold on, let me get there. You can't, with a subnet mask, you can't have like this. Not allowed. You can't mix and match zeros and ones. Ones are on the left, zeros are on the right. So that's why when we need to borrow anything, we have to start borrowing from here, like this. Okay. So traditional subnetting wastes addresses. Using traditional subnetting, the same number of addresses is allocated for each subnet. If all the subnets have the requirement for the number of hosts, then these fixed size addresses blocks will be efficient. However, most often that is not the case. Although this traditional subnetting meets the needs of the largest LAN and divides the address space into adequate numbers of subnets, it results in significant waste of unused addresses. For example, in the wide area network, you only need 2 addresses, but if you use traditional subnetting, then you're going to be wasting 28 usable addresses for each subnet. So that's where variable length subnet mask comes along. The variable length subnet mask, or VLSM, subnet provides more efficient use of addresses. VLSM allows the network space to be divided in unequal parts. VLSM subnet is similar to traditional subnetting in that bits are borrowed to create subnets. The formulas to calculate the number of hosts per subnet and the number of subnets creates is still the same. It will apply. The difference is that subnetting is not a single pass activity. With VLSM, the network is first subnetted and then the subnets are subnetted again. This process can be repeated multiple times to create subnets of various sizes. So let's look at one subnet that we had before. Subnet 2, for example, which is 192.168.1.64 up to 192.168.1.127. That was a broadcast. So if we take the subnet 2 here, and we can subnet it even further. So for example, okay, that's our subnets we start with, 192.168.1.64. That's our subnet mask, 255.255.255.192. We are given that. We can't change ones. You know, ones are here of subnet mask, we can't change that. That's what we're given with. But we can manipulate these zeros. These zeros are host addresses. But we can manipulate the zeros so we can create extra subnets. So if we borrow 2 bits from the host portion, right? These ones they were taken, but we can still borrow 2 bits here from our zeros and change them into ones. Now that subnet mask will change to 255.255.255.240 because if you have to have all 4 together, and this will give us 4 networks, and each network will have only 14 hosts, right? So when we change that, right, let me go 14 usable addresses. So if we remember, the formula was 2 to the power n for the networks, and for the host it was 2 to the power n minus 2. So we borrowed 2 bits, 2 zeros we changed into ones. So the formula becomes 2 to the power 2. So it's like saying 2 times 2 equals 4. And we have 4 zeros left. So it's 2 to the power 4 minus 2. So it's like saying 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16, 2 to the power 4, minus 2 is 14. Now, if we put it on the table, let me get rid of this all together again. Let me just, boom, get rid of it. Delete that. Okay. Now, let me put this, we do it together. So, we have the subnet 1, what we start with is what we are given, the network ID we are given with. So, the network ID we given, it was 192.168.1.64. Right? Let me just change the font so we can all see it nicely. Here. That's what we're given with. We can't start with something else. We start with what we are given with. So the first valid address is the subnet ID network address plus 1, which is 192.168.1.65. The last valid in the broadcast is easier. What is the number? It's easy to find out the next subnet ID, which is subnet 2, and then we do minus 1, minus 1. Right? So we go to the subnet 2. It's going to be 192.168.1. If you look at this separation between ones and zeros, it's happening in the 4th octet. This is the 4th octet. And this bit here, what is this bit representing? This bit represents 16. So we have to add 16 to 64, which is 80 in this case. So the broadcast of subnet 1 is the network ID of subnet 2 minus 1, which is 192.168.1.79. The last valid address is the broadcast minus 1, so 192.168.1.78, right, from 65 to 78. Subnet 2, the first valid address is the subnet ID plus 1, so 192.168.1.81. Last valid address, broadcast, is to find out, it's better if you find out the next subnet, which is subnet 3. So here we look at it, 192.168.1.1. So if you look, this bit here represents 16. So we have to increment by 16, so 96. So the second subnet, broadcast, address is the subnet 3 network ID minus 1, which is 192.168.1.95. And the last valid address is broadcast minus 1, so 192.168.1.94. Sorry, 94. Subnet 3, first valid address is the network ID plus 1, so 192.168.1.97. And to find the last valid address and broadcast is to find the next subnet ID, so 192.168.1. So we have to add 16 to 96, right? So that's 112. So the broadcast is the subnet 4 ID minus 1, so 192.168.1.111. And the last valid is the broadcast address minus 1, so 192.168.1.110. So that's the last valid address available. Now, subnet 4, the first valid address is subnet ID minus plus 1, so 192.168.1.113. And to find the last valid and the broadcast is if we find the next subnet ID, which is subnet 5. If we add 16 to 112, it's going to be what? 128. 128 is the next network. We can't touch that. That's somebody else's subnet. Subnet 3 here. So we have reached the maximum. We have reached the top. So 192, the broadcast is 192.168.1.127. And the last valid address for subnet 4 is 192.168.1.126. So what we did here, we took subnet 2, right? Those were the given addresses, and we subnetted even further. We created another 4 subnet addresses. Right, now I have for you to practice variable length subnet mask. These are the requirements. You have a network 192.168.1.0/24, and the requirements are for you to create first subnet to have 94 hosts, the second subnet to have 20 hosts, the third subnet to have 8 hosts, fourth and fifth subnet to have 2 hosts, for you to practice. Now you can stop the video and do it on your piece of paper and do it yourself, and we compare it. Now I'm going to give you a few seconds to stop the video and do it. Try it, and we'll do it together. You've done it? Okay, let's do it together. Let's start. So here when you have let me just put this like this. What was it? 192. Address that we had is 192.168.1.0, and the /24, yeah, /24. Now /24 says like this: 1 2 3 4 5. Not too fast. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. And there's 8 zeros. 1 2 3 4 5 6 7 8. The reason there are 8 zeros is because it's IPv4. IPv4 is 32 bits. Now you have 8 zeros that you can manipulate. We cannot touch these ones. Those ones are not for us, right? So what we need is host. When you're thinking about host, now you have to think how many zeros I need to reserve, right? So how many zeros I need for 94 hosts, right? Let's think, okay, 4 zeros. Okay, remember the formula for the host was 2 to the power n minus 2, right? So what we're saying, okay, what do I reserve for zeros? The formula is 2 times 2 times 2 times 2, 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 4 zeros is not enough. So let's reserve 6 zeros, maybe, right? So we change the formula like this, times 2, 6 times. 2 times 2 is 4, right? So I know the mouse recording is not good. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Well, 64 is not enough because we need 94, right? So we're gonna reserve 7 zeros, right? So saying, okay, times 2 as well, another times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So equals to 128 minus 2, 126. Okay, so now 126 is enough, right, for 94 hosts. That's the closest we can get. So we need to reserve 7 zeros. We need to reserve 7 zeros. So this 0 here will become 1. So, right, for this is what we started with. So for subnet 1, we need 94 hosts. 94 hosts. Okay, 94 hosts for subnet 1. We need to borrow. I'm just thinking if I put it in notepad in the word, might even be better. Okay, let me just put this in the word. Right. So 1 second, sorry. Okay, I'll put in the host on the word. Okay, so we have to think of first valid address, network ID. We have to think of first valid address, last valid address, and we have to think of broadcast. Right? So subnet 1, we need a 94 host, and we're gonna actually leave or reserve 7 zeros. So one of these 0 will become 1. Okay, so we change that to 1. If I put it on red so we can see it. Okay, so the subnet mask, we can say or 255.255.255.128, or you can say it /25. Right? 3 ways of saying the same thing. I can put it in the binary, I can give you a decimal, or I can give you the prefix length. Right, so okay, now the network ID is start with 192.168, what you are given, 1.0. So the first valid address is 192.168.1.1. So the network ID plus 1. To find the last valid address and the broadcast, is it better if you find the next subnet, right? So it's going to be subnet 2. Subnet 2. Subnet 2 that we require with subnet 2, how many hosts? Subnet 2, we required 20 hosts. Okay, 20 hosts required. Right. Now you start with the subnet that you're given there. You're given with the subnet. So how many hosts do we need, or how many zeros we need for 20 hosts? So how many zeros we need to reserve for 20 hosts? Okay, if we, for example, let's just copy this. Say that we reserve 4 zeros. 4 zeros. Right? The formula is like this, yeah? So 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16. 16 minus 2 is 14. Well, 14 is not enough. So we need 1 more 0 at least. Right? So times 2, 5 zeros. If we reserve 5 zeros, right? 2 times 2 is 4, times 2 is 8, times 2 is 32, times 2 is 64. Now hold on, I got it right. I'm wrong. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so yeah, that was right. 32 minus 2 is 30. Right? That's enough. So we need 5 zeros to be reserved for our 20 hosts. Okay, so 5 zeros, we're going to reserve them. 1, 2, 3, 4, 5. So these 2 ones here, 2 zeros will be changed into ones. Like this. So this subnet mask is like saying 255.255.255.224. You can represent it. Or we can represent it with the prefix. So prefix is going to be 24 up to here. 25, 26, 27. So there's 27 ones there. 27 ones. Okay, so now we need to know the network ID. That one, I want to copy this. network ID of the subnet 2. So subnet 2, the network ID is going to be 192.168.1 dot something. If we look at the increment of this bit here, that's for the next one. This one here is 128. So the increment from 0 to 128, 128. So the broadcast for the first network for subnet 1 is the subnet 2's network ID plus 1. Oh, sorry, minus 1. So 192.168.1.127, and last valid address is going to be the broadcast address plus 1. Sorry, minus 1. I keep saying plus. Minus 1. 168.1.126. I'm thinking too many things at the same time. Okay, so the network 1 is done. From 192.168.1.0 up to 192.168.1.127. Network 2, the network ID is 192.168.1.128. The first valid address is the network ID plus 1. So 192.168.1.129. To find the last valid address and the broadcast, it's better if you find the next network, which is next subnet 3. So subnet 3. Now subnet 3, the network ID is going to be network ID. It's going to be what? So 192.168.1.128 plus whatever bit is representing here between the division, ones and zeros. That bit represents 32. So 128 plus 32. So it's going to be 192.168.1.160. 128 plus 32 is 160, yeah? And the broadcast is going to be the subnet 3 network ID minus 1. So 192.168.1.159. The last valid is going to be the broadcast ID of subnet 2 minus 1. 192.168.1.158. Okay. So subnet 1 and subnet 2 is done. Now we need to think of subnet 3. Now that's the mask that we are given, right? Now how many ones or how many zeros we have to reserve to get what was the requirement? Requirement was for 8 hosts. So how many zeros we need for 8 hosts, right? So if we think of 4 zeros, 1 2 3 4 4 zeros, because 2 times 2 is 4 times 2 is 8. It's enough, but minus 2 is 6, so that's not good. So times 2 is 16, 16 minus 2 is 14, so we need to reserve 4 zeros. So the subnet mask for the subnet 3 will be like saying 255.255.255.240. You see the variable length subnet mask. Here we have .128, .224, .240, or /25//27. Now this is going to be what? / what? Or like saying /28, yeah? Right. Now let me just copy this. I put it up here. So the network ID, and this as well. For subnet 3, network ID is 192.168.1.160. The first valid address is 192.168.1.161. To find the last valid address and broadcast, it's better if you find the next subnet. So subnet 4. What is the network ID for subnet 4? Subnet 4 network ID is 192.168.1.what. If you look at this bit here, division, what's happening? This bit represents 16. So if we add 16 to 160, it's 176. 176. So the broadcast address of subnet 3 is the subnet 4 network ID plus 1. So 192.168. Sorry, minus 1. I keep saying plus 1. Minus 1. 175. Last valid address is 192.168.1.174 minus 1. So we're done. Subnet 1, subnet 2, subnet 3 is all done, right? So let me just put this less gaps here. Okay, subnet 4 now. Subnet first valid address for subnet 4 is 192.168.1.177. That's the first valid address. to find the last valid address and broadcast, it's better if you find the next network ID. But for subnet 4, what do we need? We needed 2 hosts. Subnet 4 and subnet 5, it's only 2 hosts. Okay, so subnet 4, because we only need 2 hosts, let me take this network, this subnet mask. Okay, so for 2 hosts only, we're gonna need to reserve 2 bits. So 2 times 2 is 4, minus 2, 2. Okay, so we need to reserve 2 bits, like this. And now the subnet is like saying 255.255.255.252, or you can say / 30. 252, because if you add these 6 bits together, if you add those 6 bits, it's going to give you 252. Okay, so now to find the last valid and the broadcast, it's easy if you find the next network, which is subnet 5 ID, right? So subnet 4 here, let me copy and paste it here. Subnet 5. Okay, so subnet 5's network ID is going to be what? 192.168.1. If you look this bit here, that bit represents 4, and it's located on the 4th octet. So we need to increment the 4th octet by 4. So this is going to be 180. So the broadcast of subnet 4 is going to be 192.168.1.179, and the last valid address is the broadcast minus 1. Good, that's it. Good this time. Minus 1. 192.168.1.178. Right? 2 valid addresses, 177 and 178. And for the subnet 5, its first valid address of subnet type 5 is 192.168.1.181. Last valid address and the broadcast is better if you find the next subnet, which is subnet 6. We don't need subnet 6, but we just need to find the ID, so we can go -1, -1. Okay, it's the same because it's only 2 bits. So it's going to increment on what? By 4s. So the network ID of subnet 6 is 192.168.1.184. It's going by 4 because this bit is representing 4. So the net broadcast, sorry, saying too many stall time, but that's how I'm used to it. The broadcast is the subnet 6 network ID minus 1, 192.168.1.183, and the last valid address is 192.168.1.182. Right, whoa, we've done it. Took us a bit of time, but you could have stopped and look at it. Okay, now if I go back to my slides, does it match? Yeah, I think it does match. If you look here, let me just see quickly. 0, 128, 160, 176, 180. I'm looking at just the network. 128, 160, 176. Well, yeah, that's correct. 100%. So you can see the variable length subnet mask, and we did it bit by bit. I know this video is going to get very long, but hey, it's not easy to learn the subnet. Okay, what we're going to do next is I'm going to introduce you to a website called subnettingquestions.com. Now this is nothing to do with me, but it did help me quite a lot when I was learning subnetting as well. Right, so we're going to visit that website and we're going to get this is answers on this website. It's a great way to learn. If you want to learn the subnetting, you should go to this website every day and do at least one question. Okay, so I'm going to open a new website. New browsing page. Let me organize it here. And it's subnetting questions. Subnetting. Okay. So subnetting questions. For example, it asks you a question like this. which subnet does this host belong to? Excellent, excellent question. What we want to know is what host does this host, what network or what subnet it belongs to, right? So let me open the notepad here and paste it. Now you have to think, okay, it's /25. So again, very quickly, 1 2 3 4 5 6 7 8 dot, copy these, go to the end, that's 16 24 25, and then 7 zeros, 1 2 3 4 5 6 7. Okay, so you need to look at this bit here. This bit says 25 and is increment of in the 4th octet. So we have to put up to 4th octet the numbers we are given, 172.28.128.0. And then on the 4th octet we need to increment with whatever that bit represents. That bit is representing 128. So the 4th octet we need to increment 172.28.128.128. So the question is, what subnet does this host belongs to? So we can see 132. Okay, if we continue incrementing, yeah, 172.28.128, 128 and 128 is 256. 256 is not allowed. So we know that this host belongs on this subnet, 172.28.128.128. Okay, there you go. Let's get another question. Next question is, what is the first valid host on the node that it belongs to? Okay, so what is the first valid address of this host, where this host belongs to? Okay, so if I go to the notepad, look at the, open the notepad, get rid of this. Okay, what is the first valid host? Okay, when we look at /20, right? So 1 2 3 4 5 6 7 8 dot, that's 8. I'll go to the end, 16, 17, 18, 19, 20. Okay, that leaves it 1 2 3 4, then another 8, 1 2 3 4 5 6 7 8. You can see the changes. The interesting octet is on the 3rd octet, right? The 1st octet, 2nd octet, and 4th octet, you can say, okay, that's boring octet. Things are happening on the 3rd octet, so we have to put the 3rd octet at 0. Right, so we start. Okay, the IP address 172, boring octet, 3rd octet, interesting, and then 0 again. So we can see here, this bit here represents what? 16. It's in 3rd octet, located on 3rd octet. So we have to increment the 3rd octet by 16. 172.22.16.0. Right, now we can continue incrementing. 172.22.16 and 16 is 32.0. Then we can continue 172.22.48.0. That's another 16, and we can continue. Right, there's some milestones. 172.22.128 is a milestone. The other one is 172.22.192 is a milestone. Right, one way or another is going to reach at those numbers. So we can go minus. We don't have to always go adding them up. So we can go 192 minus 16. Right, so it's going to be 172.22. So 192 minus 16 is 176. 176.0. Now 176 minus 16. So 172.22. Okay, 160.0. Until we find where does it, between where. So 171 is between 160 and 176. So 171 is somewhere here. So we're middle here. 171 is here somewhere. So the question is, what is the first valid host on this subnetwork that this node belongs to? So the first valid host is going to be this plus 1. So if I go here, plus 1, 160.1. So correct. Okay, let's do another one. That was a hard one, yeah? How many subnets and hosts per subnet can we get from this network address? So we look at this, we take this, copy it, and I go to my notepad, and I'll paste it there. how many subnets and hosts per subnet we can get with this network, right? So we have 10.00/20. Okay, let me just copy that so I don't have to write it again. Don't have to bore you too much. Here, that's /20. Why? Because 8 and 8, 16. So here up to here, 16, 17, 18, 19, 20. And then we have the rest are zeros as well, right? 12 zeros. So how many hosts we can get and subnets you can get here? So when you think this is 10, right? So class A belongs to class A. Class A is like this: 1, 2, 3, 4, 5, 6, 7, 8, and then the rest are zeros. So 0, 0, 0, 0, 0, 0, and zeros, like this. And from there, they have subnetted, right? So they have taken, how many is there? 8, 10, 12 ones. So we have 12 ones and 12 zeros, right? Because this is what you started with. That's the class A they started with, and that's what they subnetted with, right? So you have to ignore these bits because these are already taken. So these are the bits that they subnetted. So we have 12 bits for networks and 12 bits for the host, right? Remember early I said 2 to the power 10, it's a milestone, yeah, equals 1024. So 12, it's okay. So if 10 is 1024, 11 is 2048, and 12 is 4096. So you will have 4096 networks, and hosts same, 4096 minus 2. So 4094, right? This website is a bit more advanced. This will help you for CCNP as well. But hey, so we have a 4096. With this, we can have 4096 networks and 4094 hosts. There we go. Okay, these are random questions. Yeah, I haven't prepared them, right? So we take another one. There's another question. What is the broadcast address of this network? So what they're looking for is a broadcast address on this. Okay, so I'm going to copy this into my notepad. So copy, open the notepad, paste it. What is the broadcast address of this network range? So network IP address. So what we're looking is /26. So 1, 2, 3, 4, 5, 6, 7, 8. Another 8 here. So add another 8. That's 16, 24, 25, 26. 1, 2, 3, 4, 5, 6, 7, 8. And 6 zeros left. That's 32 bits. So we need to know what is the interest in octet. Interest in octet is octet fourth octet. Fourth octet. If we look, okay, we put 192.168.110.0. We're gonna increment what is the fourth octet bit is representing. This bit is representing 64. So we need to increment every octet by 64. So every on the fourth octet by 64. So 192.168.110.64. Then next one is 192.168.110.128 until we find the range. So and then 192.168.110.192. That's going to be x64. So 64 here. What is the broadcast address? It's going to be this -1, right? So that's going to be the broadcast. We can tell any question they ask. If they ask first valid address, we know the first valid address is going to be 65. If they ask last valid address, we're going to know that it's going to be 128 -1 is broadcast, -1 is the last valid. So 126. 126, and the broadcast is going to be 127. So the broadcast address for this network is 192.168.110.127. There we go. If we take another one, which subnet does the host belong to? Right, so we have a host and we need to find out what is the subnet address. So if I copy that, put it on a notepad, this host. So 240. They have given you 240. So 1, 2, 3, 4, 5, 6, 7, 8. If I copy this, that's 8, 16, 17, 18, 19, 20. That's 240. And 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Because here 128 plus 64 192 plus 32 224 plus 16 is 240. So where does it belong? Look at the interesting octet. Interesting octet is a third octet, right? First octet, boring. Second, boring. Third octet, interesting octet, right? And fourth octet is boring. So we put 10.105.0.0, right? So we start from the interesting octet, we put it down to 0. So we're gonna increment on 16s, right? So 10.105.16.0, because this bit here is located on third octet and it represents 16. So we're gonna increment every network by 16. 105.32.0 and so on. We can continue incrementing like this, but we know there is going to be a milestone 128.0. At one point it's going to reach 128, right? So we can go minus 16 or plus 16. So we can see here is 129, so we can add another 16. So 10.105. plus 16 is going to be 160.0. Oh, sorry, not 160. That's plus 32. Plus 16 is going to be what is it? 138, 144.0. Right. So the subnet, the host belongs to this host, 10.105.128.28 belongs to subnet 10.105.128.0. Yay! 10.105.128.0. Okay, you can try these at home as many times as you can and be professional in subnetting. Okay, this video I know has been quite a long video, but we're nearly done, or we are done actually. We're just going to continue the next session. We're going to do 9.2 addressing schemes. Thank you very much for sticking with it, and if there's any questions or anything, let me know, email me. And but if you can do that website, and if you are really good at it, then subnetting is covered. You have to know the subnetting, you have to be 100% at it, otherwise there's no point to continue. Subnetting is very important on the networking. Thank you very much. This has been Astrid Krasniqi, and thank you for watching my video. See you on 9.2 addressing schemes.